All right, got cut off. So here we go. Probability of 0 means it's impossible to occur. So, for example, if Miss Straub, the probability of Miss Straub is going to be running a race in the 2020 Olympics this year is 0. Okay, but the probability that I don't know, the probability that there's a whiteboard in my classroom is 1. It's certain to occur. Okay. We use other terms such as the probability, and notice this is the nomenclature. P of the event means probability of something happening. If it's 0.04, then that means it's a 4% chance, which would obviously be very unlikely. Okay. 0.8 would be 80% chance, which would be very likely. And then you have 0.6, which would be more often than not. So just some language there for when you get your probabilities. Okay, what about tools? Really important. We're going to use a lot of this. AP Stats loves tree diagrams, okay? It's a great way to get your sample space. Like if you're going to flip that coin twice, like we talked about earlier when we were showing sample space, okay? You're going to flip the coin, and the first one, you'll either get a heads or a tails. And then you show with the tree diagram how that branches out to the second coin would either then be heads or tails for each of these. And then you follow the tree branches and get your sample space written. So you have heads, 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 tails, tails, heads, tails, tails. And then you can assign the probabilities to those, which we're going to work on. Okay? Oh, yeah. By the way, that was your sample space right there, right? Okay. Other tools that we use would be the multiplication principle. Okay, this is like flipping 2 coins on the previous slide. This is a way to find out how many possible things would be in your sample space. It doesn't determine what your sample space is, it's just the number that would be in it. And sometimes you just need to know that as your denominator for probability out of this many possibilities, right? So if you're flipping the coin twice, you have two options on the first one, heads or tails. And then the second one is 2 options, again, heads or tails. So you do 2 times 2 and you would have 4 outcomes. Okay? This is really handy with bigger numbers, of course. So like take California license plates. You have 1 number, 3 letters, and then 3 numbers. That would be way too many to list. But if you wanted to know how many were in it, then let's use this multiplication principle. Okay? This would be, I'm still covering there, aren't I? Sorry about that, guys. Trying to make this better, but 10 possible number digits, right? From 0 to 9. So that's 10 digits times 26 letters times 26 letters times 26 possibilities for another letter, because you can have repeats in plates, and then 10, 10, 10 for the last 3 digits. When you multiply all that out, you get 175,760,000 plates possible in California that you can use. Now, of course, this is not counting all the special ones, and because California grew so fast, that's why they've had to go to some specialized ones to try and not keep extending our license plates forever. Okay? So, of course, a way to do this when your numbers are smaller is to get an organized list going. So, for example, here, list all the possible outcomes of flipping a coin 4 times. Okay? And so you organize it in, well, I could get 0 heads, 1 head, etc., all the way to 4 heads. And how could that happen? Notice the order of the coins falling on that does matter for us. So there's 4 ways you could get 1 head when you toss 4 coins. Okay. There's, 6 ways to get 2 heads when you toss the coins. Now you have probability for all of now, of course. How would we get, if we're tossing a coin 4 times, how many total possibilities would there be? There would be, using that counting principle, let me hide this again, okay, 2 times 2 times 2 times 2, which 2 to the 4th, 16 possible ways. And if you look here, you'll see 16 different ways that you could get your 4 coins to fall out. So if you're going to do probability, the probability of getting 2 heads would be 6 out of 16, okay? Of course, you'd reduce your fractions. Right? You also use a sample space chart. So this is really important, especially when you guys are doing problems. We do a lot of this. You're going to do it in your homework with rolling 2 dice. Make a chart and so here's the sum.